And now we come to my favorite method of solving a system of equations, elimination or linear combinations. This is where we're going to eliminate one of the variables. I like it because it doesn't matter what the coefficients are of your variables. One of the things you're going to do is you're going to arrange your equations with like terms in columns. So you're going to get all your x's and y's together on the same side and lined up. It doesn't actually matter what order you put them, as long as they're lined up, stacked up in a column on top of each other. The goal is to obtain coefficients for x or for y that differ only in sign. So if we look at our first little equation here, there's no good way to make a 2 look like a 5, but there is a way to make a 3 look like a 9. If we multiply the entire bottom equation by 3, we'll have a negative 9x on the top and a positive 9x on the bottom, which is going to allow us to eliminate the x's. So I'm going to go and multiply everyone on the entire bottom equation by 3. My old equation stays exactly the same, and my new equation is now going to be 9x minus 6y equals 6. Do not forget to multiply times every single term. And now we're just going to add these two together, and the negative 9x and 9x cancel out, and we're left with a negative 1y equaling 7. Now no one cares what negative y is, we want to know what y is equal to. So I'm going to multiply both sides by a negative 1, and I get that y is 7. Again, this is a coordinate point, so we need to find out what x is. And you can plug y into any of the equations that you have here. I'm going to choose the bottom equation because it seems the least troublesome. So I'm going to say 3x minus 2 times 7 is equal to 2. So we're going to get that 3x, whoops, sorry about that. If you find that something is amiss, go back and try it again. We know that y equals negative 7. Yikes. So I get 3x, and I'm going to get plus 14 equals 2. So when I subtract 14 from both sides, I get 3x is equal to a negative 12. And x is going to come out to equal a negative 4. And so your coordinate point is negative 4, negative 7. If you want to know if this is really the answer, you can plug it into both equations, and it should yield true results. Now why don't you try it? Now as we look over here, you can easily make a 2 look like a 4, or a 3 look like a 6. I sometimes like to use the one that already has a positive and a negative available to me, but either way you can eliminate the x's or the y's. Try it out, and I'll see you tomorrow.